Hey, welcome to the Explainer. Today, we're going to dive into something called arrays, a really basic but super powerful idea in programming that helps you organize tons of information. Let's see how it all works. So let's imagine for a second you've just coded an awesome game, and now you've got to track the top 10 high scores. What's the first thing that comes to mind? Maybe creating 10 different variables, right? You'd have score 1, score 2, score 3, all the way to 10. I mean, it works, but it's pretty clunky. And what if you wanted the top 100 or 1,000? Yeah, that would be a total nightmare to deal with. Well, you'll be happy to know there is a much better, much cleaner way to handle this. And that solution is the hero of our story today, the array. It's this amazing tool made specifically for storing lists of data. So what exactly is an array? Okay, here's the official definition. It's a data structure with a bunch of elements, and all those elements have to be the same data type, so all numbers or all bits of text. But here's the magic trick. You get to all of these different items using just one name and a special number called an index. You can think of it like a filing cabinet. The whole cabinet has a name, say finances, but each drawer is numbered so you can get to exactly what you need. Okay, so to really get this, we're going to start simple with the building block of all arrays, the one-dimensional array. If you get this, you get the whole concept. All right, check this out. This is a perfect picture of a one-dimensional array we're calling my list. And that mailbox analogy, it's perfect. The entire row of boxes is our my list, but each individual box has its own unique number, its index, starting from 0 and going up to 9. So we have 10 slots for 10 numbers, all under one convenient name. So when you're telling a computer, hey, build me one of these things, you have to give it 4 key details. First, the name, in our case, my list. Second, the starting index, which in programming is almost always 0. Third, the last index, which is 9 for us. And finally, you have to tell it what kind of stuff it's going to hold. Here, it's for integers. And this right here, this is what that instruction looks like in pseudocode, which is kind of like a simplified universal programming language. See? It spells everything out for the computer. Declare an array, name it mylist, make the slots from 0 to 9, and make sure it holds integers. That's all right. Let's put this to the test. If we look back at our mylist array, you can see the number 19 is just sitting there in one of the slots. How would you actually ask the computer to pull out that specific value? Easy. You use its index. Since 19 is in the slot labeled with a 1, we just ask for my list at index 1. The computer knows exactly where to go, and bam, it gives you back the number 19. That index is the key. It's what unlocks every single piece of data inside the array. Okay, so we've got the single row down. What's next? Well, we can add a whole other dimension. We're about to go from a simple row to a full-on grid. You can really see the jump here, right? On the left, there's our simple list. But on the right, boom, it's a whole table, a grid with rows and columns. It really is like going from that one little row of mailboxes to that giant wall of them you see at the post office. So let's zoom in on this 2D array, which we're calling my table. It's basically a spreadsheet. You've got your rows going down, numbered 0 to 9, and your columns going across, numbered 0 to 2. Now, to find any single value, one number isn't enough. You need 2. You need a row number and a column number. It's just like finding a point on a map with coordinates. So let's try it. See the number 98 in there? How do we pinpoint that exact value? Well, we just use its coordinates. We go down to row index 5, then we slide over to column index 1. And right there at that intersection, there it is, 98. So the command is simply mytable 5, 1. Okay, so theory is great. Diagrams are helpful. But what does this stuff look like in the real world? In the actual programming languages that people use? Let's take a look. So here we've got our simple one-dimensional my list in 3 really common languages. You can see the syntax, the specific punctuation and keywords. It's a little different for each one. Python likes square brackets, Java uses these curly braces. But look, the core idea, it's exactly the same. You give it a name, and you give it a list of your items. And it's the exact same story for our 2D arrays. I actually love how Python does this because you can literally see that it's a list of lists. And in Java, those double square brackets are your big glue right there, that you're not just working with a list, you're working with a grid. The way the code looks actually helps you understand what it's doing. So, if you remember just one thing from all of this, let it be this. Arrays give you the power to use one single name to organize and manage a whole bunch of related things. It's all about keeping your data neat, tidy, and efficient. Think about it. High score lists for games, your contact list on your phone, tables of scientific data. Arrays are hiding in plain sight absolutely everywhere. They're one of the first and most important tools for any programmer. So now the real question is, with this powerful new way to organize data on your toolkit, what are you going to build?